Hello students, in this video we are going to talk about exponential decay. The second type of exponential function is exponential decay. Exponential decay is a function f of x equal b to the x power when b is greater than 0 but less than 1. In this case, you can tell like either in fraction way or decimal way, 0.5, 1 over 3, 1 over 2, always between 0 and 1. And type of the graph, it's a continuous graph. Again, is different from the previous one. When x is equal 0, the b to the 0 power is going to give us again 1. The graph is decay, so it's going to go this way. We have the asymptote again, x-axis, and that is the value of 1. The domain for the graph are all real numbers. As you can tell, the range are positive real numbers because here we are dealing with the asymptote. And asymptote is the x-axis. And you know that asymptote is a line that the graph approaches but never ever crosses it. So the intercepts here are x equal 1 and y equal x equals 0 and y equal 1, as we said before. Now in this lesson I'm going to talk about exponential growth that you can model with the exponential decay that we talked about with a constant percent of decrease over specific time periods. And the formula that we are going to use is a equals a 1 minus r to the t power. So let's go and discuss a little bit about this formula now. We talked about exponential growth formula, and you know that when we have an exponential growth, we have a equals a times 1 minus r. In this case is going to be plus r. That's the difference between exponential growth and exponential decay. In this case we have an exponential decay. Now in exponential decay, what is called 1 minus r? Let's review a little bit the previous lesson. 1 plus r is called the growth factor, as you remember, and we use the growth factor a lot in real life problems. In this case, since we have 1 minus r, we are going to deal with exponential decay problem. And we are going to see a couple of exercises and word problems where can we use the exponential decay in the real life situation. You can discuss with each other now for a moment and talk about the difference between exponential growth and decay. What do you think? And after that, you can create your own problem, like a real world problem, a real example. So how can we use an exponential decay? Remember, we use the exponential growth in our lessons. So for that, we're going to take a couple of minutes and think about that. After this time, I'm thinking to share with you, like for example, where can I use in real life? I would think myself, and I am thinking up loud here. For example, if I get a real life situation, like a tea, a cup of green tea. A cup of green tea always have caffeine on it, especially when it's the caffeine is on the tea. The caffeine eliminates from the body approximately by a percentage. So our system, for every hour, lose 12.5% of the caffeine on the body. So what is going to happen in this case? So the caffeine is going to go down every hour more and more and more by a certain percentage. So in this example, I am not dealing with exponential growth because my amount of the caffeine on the body is not increasing, but my amount of caffeine on the body is decreasing, and is decreasing by a certain percentage. So this is a great example from a simple real life that shows you where we use the exponential decay in the real life. Examples like that you can have many examples. You can have a cup of coffee with a caffeine example. You can have the amount of medication in our blood, in our system. When you drink the medication, you have all the amount, but after an hour, a certain amount of medication is dissolved in your system, is gone. So that case shows us again another exponential decay case. So exponential decays are really useful in the real life. They can be useful in the economy cases. They can be useful in health, phones, attendance, science. Maybe the population was growing, maybe something happened, the population was decreasing, or represent the function what happened if something happened in science, in the phone, for example, like what happened when you talk and the wave of talking spread out, but spreading out can be smaller and smaller. So in this case, we're dealing with the exponential decay. So in this lesson, I'll discuss with you exponential decay graph. We graphed it together and we discussed about the decay factor, and we introduced a formula that is called the decay formula, and is a function of t equal a, open parenthesis, 1 minus r, close parenthesis, to the power of t. 1 minus r is called the decay factor. Thank you.